Okay, page 136, number 8. 1,300 kilogram car. 1,300 kilogram. Accelerates 1.6, and this is east. Meters per second squared, east. Friction. Force of friction equals 3,800 newtons west. So it's accelerating east, but it has force going against it west. Draw the free body diagram. And, okay, so here's the free body diagram. This is force of gravity. This is normal force. This is the applied force. Oh, wait, it's going east. This is the applied force. This is the force of friction. Then the second part of the question, which I'm sure is the harder part, determine the applied force acting on the car. Okay, so remember, so the net force equals the force that's applied plus the force of friction. When I say plus, it's because that friction is going in the opposite direction. We know that this thing is moving at 1.6 meters per second squared. That's going to be the net force. So for the net force, that equals mass times acceleration. Mass is 1,300. Acceleration is 1.6. So, calculator. Um, 1,300 times 1.6 equals 2080. 2080 newtons. That is the net force. So that means that this frictional force is lessening the applied force. So we have to add frictional force to this. Frictional force is 3,800, so force of friction equals 3,800. Therefore, the applied force is 2080 plus 3,800, which equals 5,880. So in sig figs, 5,900 newtons, and this is west. If we're talking about magnitude, now I want to go up here for 1 sec. This one was east, friction was west. That's why we're adding. If we're just looking at the magnitude of these, then it would be just Fn equals Fa minus Ff. We may need to talk about that. Remind me at the beginning of class if there's questions about that.